left off on the notes on infinite rectangles. However, I do know that we didn't get finished. So if somebody talk to me, people. What are we at here?
Second problem for the third page.
What is that problem? My page is not so. Okay, so let's get caught up to speed. What do you say? What do you say? We're going to pick and choose a couple examples because we need to get through a little more here. All right, so if you recall, the idea is to get a formula for finding the area under this curve based on any number of rectangles. So if I said, give me an estimate of 2 rectangles, you could just plug 2 into your formula and give me your estimate and so on, right? We say we start by taking the total region, which is 3, dividing it into n chunks. And each chunk then, or each delta x is 3 over n. So each base is 3 over ny. Oui? Okay, that delta x. The x, the first x that goes into the function then, because we're using right hand, we would go to that first division over. If I started at 0 and went 3 over and over, I would be at I thought that was an easy question, but apparently not. If I started at 0 and went over 3 over n, I would be at 3 over n, because 0 plus 3 over n is indeed 3 over n. If, in my second place I drew my height, I went another 3 over n over, then x2 would be 2 3 over n's. And x3 would be 3 over n's. And the nth x, or the last x, would be n 3 over n's, which simplifies to 3, which makes sense because they're using the right a, right? Therefore, the heights are f at different x's, and those different x's are just some number or multiple of 3 over n's. 1 3 over n over, 2 3 over n's over, 3 3 over n's over. I counting. I counts at, we start at 1 3 over n, so I starts at 1 and ends at n. Oui? All right. After that, we plugged in the function for this problem. In this case, the function is not just some general f, but 1 plus x squared. So it would be 1 plus blank squared. And in that x goes I 3 over n's. Oui? All right. Now we want to isolate the I summations. This is where one person can do things differently than the other in terms of speed. This is 3 over n times the sum of a lot of stuff. So I could pull 3 over n out. Likewise, I would have 1 plus one of these, and then another 1 plus. So I could say I'm going to have a whole bunch of 1's and 3 over n times a whole bunch of the other guys, I 3 over n's quantity squareds. Basically just split up the sum into separate sums. Cool? Can I get a cool? All right, thank you. All right. This I'm going to leave for a second. It's pretty simplified already. This, it's the I that's counting, and each time I just have another 3 over n. So I can pull that 3 over n squared out and altogether have a total of 3 cubed, or 27 over n cubed out, and just focus on the summation of all the different i's. Oui? Now, this, just in terms of understanding, the whole way a summation notation works is this tells you the first I in through the last I in. So when I equals 1 is put in, what comes out of the function? 1. And then you add that to when I equals 2 is put in. What comes out of the function? 1. And then you add that to I equals 3 goes in, and you add a 1 until you've gone through all the numbers it tells you to go through I equals n, and you add a 1. So altogether then, how many 1s would I have? N of them. And n 1s adds to 10, yeah. Now, that summation then can be replaced by just saying that's just going to add to n. Whatever n is, that's how many 1s you're going to add, so it would total to n. 3 over n is then just waiting for it to be multiplied. Cool? The 27 over n cubed, that means when I equals 1, you get 1. Add that to when I equals 2, you get 2. Add that to when I equals 3, you get 3. You would add all those numbers until the last number in n. Now that's a little more complicated because it's not just constant. 1 plus 2 plus 3 plus blah, 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 blah. And that requires a bit of a cool formula. I give you those formulas. The formula for adding a bunch of numbers, linear growth from 1 to n is n times n plus 1 over 2. Those formulas will always be given to you. I will not expect you to memorize them. Now, what I found there, or simplified found, is a formula for finding the area based on any number of rectangles you choose to give me. So I could clean this up into what? Oh, this doesn't seem good. Oh, this should be I squared. Why didn't you say something? You don't even know what you're doing, do you? This whole thing was squared, yes? So this should be I squared, the formula for which is not that, but obviously I don't have one person thinking critically. The formula for that is actually that guy. See? I suppose I could clean it up if I wanted. I could take out an n, and I could take out a 3, and all said, get something big like 9 times n plus 1 times 2n plus 1 over 2n squared. We? All right. So if I said, all right, calculate a sub 2, what would I be doing? What would it mean? It would be an area under the curve using 2 rectangles for my estimate. A sub 3 would be using 3 rectangles and so on. So that's a formula that would give you an estimate based on using any number of rectangles once you put it in. Cool? I could do analytically then, take the limit as n goes to infinity, or with a computer program I could put that in and put in any n I wanted, or a calculator program. All right. This one gets a little hairy, so we're going to go to this one and do that one together in the interest of time, all right? What makes this different is that guy. When you start at non-zero, then your life gets a little more complicated. I will show you. I am still taking area under a curve, and 1, 2, I should have spread it out a little more, 3. I still am saying the area as a function of number of rectangles is delta x for the bases times f of x at some x for the heights. That to me is a good starting point. It is the basics of Riemann. Delta x, what's delta x in this case? How wide is each rectangle? 2 over n, okay? F at. Now, if I'm using right-hand rectangles, then I'm going to start at 1 and go over a delta x, meaning my first x is not just a 2 over n, but 1 plus a 2 over n. And my second xn is to start at 1 and go 2 delta x's over. So what is x sub I generally? X at any point where I'm going to draw my height is 1 plus some number I delta x is over, right? Now that's going to make my life harder because that's a big ugly thing going into the function. Instead of just a delta x, it's an a plus delta x. That makes things gross. But it is what it is. All right. The 2 over n I'm going to pull out front right away. And I'm going to go formula specific. In this case, the function is x squared. So that means 1 plus I 2 over n's is going to get squared. What is the expansion of a plus b squared if I want to multiply that out? A plus b squared is a squared plus 2ab plus b squared. That might help as a kind of blueprint to plug into. All right, so a squared is just 1. 2ab is 2 times 1 times I times 2 over n. That b is gross. Plus b squared is I times 2 over n all squared. Stop me if I'm in there. All right. Now I'm going to break this into 1, 2, 3 different summations. Each one will have a 2 over n out front of it. From that guy, right? The first one will be the sum of all the ones. The second one will be the sum of all the 4 over n times i's. Do you see that? Now the 4 over n, can I pull that out front? Leaving me with just the i's. You see? And then the last guy, I could square both, and the 4 over n squared I could pull out front, leaving me with just what inside the summation? I squared. Broke it into pieces. Good. Cool? All right. Now, it says to write an equation for area without summation notation. Obviously, I'm not there yet. So now I need to dump the summation notations. What is this summation equivalent to? Adding 1 to itself n times adds to n. 8 over n squared. We have a formula for 1 plus 2 plus 3 blah, blah, blah. It's n times n plus 1 over 2. And 8 over n cubed. We have a formula for the sum of a bunch of squares added. In a pattern, it is n times n plus 1 times 2n plus 1 all over 6. Again, you don't have to memorize those, you just have to know how to use them and when. Okay? Now, typically I would then continue on and take an infinite limit of that, but that's not the question asked. It says just write a function for the area without summation notation, so am I done? I finished without summation notation? I'm good. Okay. All right, my end goal then is to then do all that process, then take the infinite limit. Do you want to do one all the way through, or should we just do one off homework 10 together? Do you want your notes? I don't know if you even use these notes or not, but do you want to do this one all the way through, or go to homework 10 and try one off homework 10? Homework 10. Okay, I heard somebody say homework 10, so let's do it. Okay, homework 10, I got a couple right off the bat here, I believe, right at the top of homework 10. Yay? Do you feel like you know enough to do one all the way through on your own, or should we walk through one together and then you do the next one? It's that one. Okay, so I don't care if you graph. I'm kind of a visual guy, but sometimes it confuses me, so it's up to you. I definitely would like you to show the big idea to start with, and then gradually get more specific. I am willing to accept a little combinations of steps, but let's not get carried away. Delta x, what is it? 10 over n. And what about x sub I? Remember, the x at which you draw the heights depends on where you start the region at and how many delta x's you've gone over. Where are we starting the region here? 0. So the only thing that'll matter is how many delta x's you've gone over. So some number of I 10 over n's over. Are you cool? Or are you, if you're not clear on where that's coming from, that just represents how many increments I've gone over to draw height at. All right, a little more, that's from 1 to n if we're using right-hand rectangle. All right, now we're going to start to do a lot of cleanup. I could start by bringing out the 10 over n out front of the summation. And I could also plug in the function itself. For this problem, it's 2 plus blank cubed, and inside that blank is the x of some number of I 10 over n. Sweet. All right. Now, we want to separate. So we're going to have a 10 over n times the sum of a bunch of 2's, and we're going to have a 10 over n times the sum of a bunch of cubes. I could also pull the 10 over n cubed out. So besides the 10 over n delta x I had, I would also pick up another 10 cubed or 1,000 over n cubed from inside of it. Wait. Leaving me in the summation only I cubed. Cool. All right. Now let's replace the summations. What is the sum of a bunch of constants? So it's just that constant, how many times? And that's just n times. So 2n times, or 2 times n, is the sum of all those 2's. Here, I'm looking at maybe 10,000 over n to the 4th times the formula for sum of cubes. I believe it's n times n plus 1, that all squared over 4. Okay. Or I guess you could also say n squared, n plus 1 squared, all over 4, whatever you want. All right. Cool? Now, I don't like to have to rewrite that over and over again, so I'm going to name that a sub n, or area, as a function of n. You could write it, rather than a subscript, you could say that's area as a function of n. But if, in this case, they didn't want me to just stop at, without the summation. They want me to actually get the perfect area, then what do I need to do? I'll get perfect area if I take the number of rectangles to infinity, right? Now, if I take the number of rectangles to infinity on that thing, which I'm going to just call my area function, rather than rewrite it all, well, time for end behavior skill. What is that first guy simplified to be? 20. What about the end behavior of the next guy? First of all, do the powers work out to a wash? Yeah, n to the 4th over n to the 4th. We're cool. So 10,000 over 4 is 2,500. My total estimate, or my total area then, is 2,520. Say I had time on a test to kill, and I wanted to check my answer. How could I check my answer? What's another way of finding area under the curve? It's infinitely better. Integrate. So if I integrate 0 to 10, this actually frustrates students more than anything. Why don't I just do that? It is 2x plus 1/4 x to the 4th from 0 to 10 is the antiderivative. 20 plus 10,000 over 4 minus zeros is indeed the same. Boom. But it wasn't as mentally challenging. I mean, really, which one is going to really impress the people that look at your paper? They're going to look at that and go, man, she's smart. She's smart. That's how we get you chicks at the bar. What?
What word do you want us to show with, like?
Oh,
And behavior.
oh, none. Oh, just do it like that. I mean, I mean, you guys are, yeah. That's good. Okay. Are we good? Do you want to try one on your own? Or, oh, well, this is on the homework, so what the heck? Have you already done this? Is this all wasted time? Do you already do this, or no, you're starting to get it, you want to do this one? Second one? All right, try this one, and we'll walk through it together in a minute. How we doing? Kind of like school, how we do? Now, first of all, don't worry about if you get a negative, because we know we can have negative area, given if the function is mostly below the curve, so that's cool. Did I go too far? Should I give you a second? How we do? Okay. I have the benefit of doing lots of arithmetic every day with my pre-algebra students. You guys, maybe a little calculator dependent, but maybe not. I imagine you've had numerical success in your whole academic career. All right, did you get negative 224 over 3? Are you still working? Are we good? Okay. This one, it really can be, I think, a nice compare and contrast between left-hand rectangles, but this combination with starting at 0 and a compound, it's a little too much. And so, I don't know if you've already done this, but would you object to me making it a little easier? You would object or you would not object? Okay. So let's go with just looking at x squared. The point I want to make is I think you know that if you take the number of rectangles to infinity, then left hand, right hand won't matter. You'll get a perfect area either way. How does the summation compare, though? How could they come out the same when it feels like they should be different? Remind me, when you do right hand, actually let's just do the right hand fairly quickly because it's what we have been doing. That's the normal right hand, yeah? The left hand will be different in that instead of starting at 1, you're going to start at 0. You're going to use the left end of the edge rather than the right. So you'll start by not putting in any delta x's. You're just going to start at your starting point. And you're going to end, instead of all the way to the right at n, you're going to end one more to the left of that, which is ending at n minus 1. You remember that? Okay. Now then, a lot of the work's going to look exactly the same. I could put a delta x in. What's delta x in this case? 6 over n. Each base would be 6 over n. F at. What's going to go into the function? X of I will depend on our starting point plus how many deltas over. So x of I is negative 1 plus 6 over n I times over. Okay? That would be the same as over here. We'll talk about that in a second. Let's proceed. If the function is to square, then that means squaring negative 1 plus 6 over n I times. When I do that, using our binomial pattern, a plus b squared equals a squared plus 2ab plus b squared, I'll get 3 terms. First of all, I'll get negative 1 squared, which is just 1. Then I'll get 2 times negative 1 times 6 over n I times, and I'll get b squared, which is 36 over n squared I squared. Correct? All right. If I break that into many, I would have 6 over n times the sum of all the 1s. Then I'd have 6 over n times negative 2 times 6 over n times the sum of all the i's. Then I have 6 over n times 36 over n squared times the sum of all the squares. Cool? Are we cool? Okay. If I replace each, what's the sum of all the ones? N. Negative 72 over n squared. The sum of all the i's? N times n plus 1 over 2. Wait. That's a mistake. And then 216 over n cubed times the sum of all the squares, n times n plus 1 times 2n plus 1 all over 6. If I take the infinite limit on that, then my answer approaches or converges on what? Yeah, so what? You forgot 2x. So it's x squared plus 2x. Oh, yeah, I dumped it, so, it was gross last period, so thank you. Oh, shoot, I made a mistake. All right, how about this? Where does this go to? This guy goes to? Oh, sorry, this guy goes to 6. Where does this guy go to? -36, and this guy goes to something like 216 times 2 over 6, which is something clean, yes, 272, because you get 72. I'll assume I'm good. 6 minus 36 plus 72. What is my final answer? 42? Oui? Cool? All right. I'm not going to redo the whole thing, but let's talk about how this would compare. This would be the same for left hand. This would be the same for left hand. This would be the same for left hand. This part would be the same for left hand. This would start to change once I got to the summations. So 6 over n ones from 0 to n minus 1. How many ones do I have? Do I have n or n minus 1 ones? If I start with I of 1 and go through n, how many n's do I have? N terms, right? Do you agree? If I start at 0 and go through n minus 1 terms, how many terms do I have? Yeah, it's still the same for rectangles. I'm just using the left side instead of the right side. So how many ones do I have? I still have n of them. Next guy, I still have negative 72 over n squared times a bunch of i's. But I'm going from 0 to n minus 1. All right? Now, I know that if I start at 1 and go to n, it's 1 plus 2 plus dot, 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 through n, and it adds to, by formula, this, yeah? You with me? Okay. What about if I end at n minus 1? 0 plus 1 plus 2 plus... Is it going to add to the same? This guy has a 0, but that's a wash. What this guy doesn't have is a n. So it's going to be like that, but take away n. What doesn't it have? It doesn't have an n. So as far as a formula for the sum of that, when it ends at n minus 1, it actually is just like the normal formula, but take away the last term n, which never gets to happen. Cool? All right. Likewise, this 216 over n cubed, it's like the normal sum of squares, n times n plus 1 times 2n plus 1 over 6, but without the last term. What's the last term in the sum of squares? You never see n last n squared, right? Okay, so just big picture here. We're talking the difference between left and right hand. Now it feels like this is going to come out different, yeah? Because of those, I mean, shouldn't this be different? But what happens when you take the n behavior? As n goes to infinity, This still approaches 6. What about this? Does that come out to anything, considering that when I distribute, I have 72n over n squared? Is that what happens to the n behavior on it? It goes to? Are you with me? N over n squared goes to 0. And so this won't matter. It's still going to come out to the 72 over 2, or the 36. And this guy, it's just going to be about this. This would be n squared over n cubed. It would go. And so at the end of the day, then, it doesn't matter. This is negative. Doesn't matter if it's left hand or right hand. With the infinite limit, it does come out to be the same. That said, right hand makes a lot more sense. Okay, now my question is this. Shall we keep going with set 10 now that we're in the summation state of mind, or should we go back and go over questions on review 9? Do you want to do, let me ask you this, because you are just basically sitting there like a bunch of slips. This one is the hardest one on review 10. Using or writing a calculator program to find area based on anything. Would you like to talk about that? Great. Okay. If you recall, the function, actually the question was estimate this integral from 0 to 3 of x root 3 minus x dx. Estimate using, first of all, right-hand rectangles, or at least I'll do right-hand rectangles, then left-hand rectangles, and tell me what would your estimate be based on 4, 8, 12, did it also ask for 16 and 14. Okay. The whole goal being that you start to see the area converging on a upper limit or a number. The more rectangles, you don't get more area, you get better area. All right? So, are you ready? So what do we do? Okay, so that was the hard part. Okay, I've got this thing, I'm supposed to use my calculator. Well, it's doggone hard to use your calculator if you don't know what to put into your calculator. So you have to do some paper and pencil work first. Let's go right. How do we typically find area under a curve? By summation notation? Delta x times f at some x's, yeah? Good start, good start. What's delta x? 3 over n, and f at what x of I? Just I 3 over n. Okay, cool. I need to be able to work this based on any number of rectangles. All right. Okay, so rather than retype the function each time, let's get the function in there first. What do you say? So would you put in the function x root 3 minus x? We're going to need that. We don't want to have to type that every time, we? Okay, now we then want to make the summation in here. Now, we can do that in the graphing menu, or we could create a function in the home screen. Now, I think based on last class going disastrously, let me try this a different angle here. Would you go to your home screen, and we're going to create a function that does the summation. Cool? Now, when you create a function, let's call it f2. f2 parentheses. Now, we're going to, this summation is not a function of x. It's a function of what? N, the number of rectangles. So it's a function of n. All right, now this is a, and then close the parentheses. Can you see that okay? Or do I need to make that bigger? No, let me go bigger. Okay. Oh, that's the wrong way. Screen only. There you go. Poop, cool. Okay. That's same as I had before. But anyway, now this is the important function here. When you want to define a function, you see that little blue colon equals? That means basically I want to create a function, let it equal. So do colon button next to 9, and you're going to say let this function be defined as, now we want to create a summation. We want to create this. The best place to go to summation is right in that same place, but not the blue. Next to the 9, you'll see the summation button or submenu. Choose it, maybe, preferably. Okay, boom. Type in what you see. I equal 1. To n. Three over n times, and then we want to use the function. So it's in there, vars, function 1, and we want the function 1 at some multiples of 3 over n. So I times 3 over n. It says done. Cool. I have identified, you have defined your function as such. That is F2. Now, I want to know what would the area under this be if I estimated it using 4 rectangles. So I'm going to use my program. I want F2, so call it F2 at 4. And if you use 4 rectangles, you would get 3.683. If you use 8 rectangles, I can't see this. 3.995. So on. Now, hopefully, as you add number of rectangles or add rectangles, you should get better and better estimate. So, question is, do you? What do you get? What did you get by the time you got to 20? Actually, 4 point what? Oh, I thought 4 was the roof, but maybe not. 4.118? Okay, cool. All right. Let me think about this for a second. Pause and think. This is this is nothing. That's what the function looks like. So will right-hand rectangles be overestimating, underestimating, or a little bit of both over that region, 0 to 3? Yeah, on this part, it's going to be overestimating, but after here, it's going to be, actually, it's going to be overestimating, but then underestimating, yeah? So it's going to be a little mixture. So I'm not sure if my true answer is going to be above or below that. Now, let's talk left-hand. Let's create a new function for LRAM. LRAM. How will it be similar? How will it be different? N minus 1. It'll go through n minus 1 starting at I equal 0. But in every other fashion, the same. 3 over n, f at I, 3 over n's. I'm going to call that F3. You should be on your, yep. Okay. All right. So we have 18 done. Should I give you a minute to do LRAM, or should we go to other questions on review 10? Questions, or do you need answers? Do I have anything posted as far as keys? just the odds. Oh, man, sorry. I will probably work keys for all three homeworks and post them online to help you. What about other questions on review 10? Is there anything else you want to talk about in review 10? Bless you. This guy? I don't know. What did you say? Starts at 2. I know delta x is 3 over n, so right away that and that are out. Is there an e? Okay, I don't know if I get it cut off. All right. What about the function? So the difference seems to be just k over n versus 3k over n's. Which one is it? Yeah, remember it's f at the starting plus some number, they're using k, of delta x's. In this case, delta x is 3 over n, so it should be some number of 3 over n. It is 2. Okay. You should not have chosen A for problem 3, right? 2 definite integrals, that summation would equate to. What's one thing this could be the same as? Let's start with the limits of integration. They must be 1 apart, right? Okay. So let's say I started at 0 and went to 1. If that were the case, then what's the function? 2 plus x quantity squared. What if you started at 2, then the upper limit would have to be 3, but then what would the function be? This would be more of a part of the original point, so the function would just be x squared. Okay, this is, you could, if you thought, I just don't get why that's the same, just think visually. Graphically, this is a parabola shifted left 2. And you're talking this region, 0 to 1. This is a parabola, normally at the origin, but 2 to 3 over here. Those could absolutely be the same. Yeah. Okay. How about 16? You don't have the answers to those, and I think I have at least one mistake in there, maybe multiple. They gave you in the book something about f from, I can't remember. Was it 3 to 6? 2 to 6. Okay. Did they tell you what 2 to 6 was? Was it equal to 8 or something like that? They gave it to you in the book, I think. 8? Okay. It was 10. Okay. Excuse me. All right. So what's your u sub here? What would you like? You use u sub when you have a function within a function. So you'd like u equal x minus 2. Therefore, du is dx. That's cool. But the limits change. If x is 4, that would imply that u is 4 minus 2, or 2. And if x is 8, that would imply that u is 8 minus 2, or 6. So this is 100% equivalent to that, and therefore it's 10. Wait. Is this one I have a mistake on? Should it have been 1 to 3, I think? I think it's supposed to be 1 to 3. What's the u sub? U is 2x, therefore du is 2 dx. When x is 1 is what it should have been, sorry. U is 2, and when x is 3, u is 6, making the integral 2 to 6 g of u times 1/2 du. And that then would be 1/2 of whatever the value they gave you, which I had no idea what it was. -2. So I had an error there. If you thought it doesn't even make sense, 2 to 3, then you're right. I screwed up. Okay. Okay. Well then, we didn't get to anywhere close to this number of questions. So 3 sets due tomorrow. Now, if you're thinking, wow, this is really good stuff, my record is 11, so we're not close. I easily get 11 sets back up. Okay? No worries. We'll get there. Now, if you haven't done any of these two sets, well, then you should recognize it. Okay? But if you just keep up, we're good. We'll get caught up on questions. Have a great day. I will post keys online so we can maybe get caught up a little bit.